Hey champions, what's up? So in this video we are going to solve LeetCode 2962, which is count subarrays where max appears at least k times. It has been asked in Amazon, Adobe, Meta and Apple in just last 6 months. So let's dive in. Here's the problem statement where you have been given a nums array and an integer k. Now you gotta find all those subarrays and return the count of all those subarrays which consist of max element at least k times. Let's see the example. So here we have 1, 3, 2, 3 and 3. Now we gotta see that how many subarrays we are getting where max element, which is 3 over here, is appearing at least 2 times. Let's see how many subarrays we have which satisfy the given condition. So we have the outer one, this one, 1, 3, 2, 3, and then we have this one as well, 1, 3, 2, 3, 3. Count of 3 is greater than 2, which is 3 over here. And then again we have this as well, 3, 2, 3, 3. This should also be in the bucket, 2, 3, 3. This 3, 3. And we have this 3 to 3 as well. So the first approach which will come to our mind will be the brute force approach. So let's see like how we'll do the brute force approach. So we're gonna try for all those subarrays. We'll be making from I to j. We'll be using 2 for loops and we'll be making subarray from element I to j, including both indices, and we try to find if in that subarray the occurrence of max element is greater than k or equals to k, then we include it as answer, otherwise we exclude it. So the time complexity is big of n square. We are taking 2 for loops. So we have code over here. We have taken out the max value using the simple STL function, and we are storing answer. Initially it is initialized as 0, and we are taking all those subarrays and finding out whether that subarray contains the count of max element greater than equals to k. Then we simply do answer plus plus and we simply return the answer. That's pretty simple. But how can we optimize the code? If you give this as answer in your interview, it's not gonna help you. You need to optimize it. So anytime we see the problem, something stating that you need to find out subarray satisfying the given criteria, the thing which should pop up in your mind should be this sliding window technique. So we gonna use 2 pointers and we gonna find that how many subarrays are satisfying the given condition. Let's see, let's try to do the rundown of this method and you'll get the clarity. So we'll be having left and right pointers over here, and we check for whether the count is greater than equals to k, then we will do something, right? Let's see. So initially it is pointing towards the first index. Till now we don't have any of the max element, so we increment the right. Now right is over here. Now we see count equals to 1. This is still not greater than equals to 2. Now again we increment the right. Now right is pointing towards here. Same case. Now we do right plus plus and right is standing over here. Now we check. Now the count is 2. So this is the valid subarray. Now here comes the catch. Now one thing you can deduce is that if this subarray is satisfying the condition, then all those subarrays including this subarray will also satisfy the condition. So how many subarrays are like that, including this left and right? So we see this one and this one as well, the outer one. So how do we take out the count? We can simply do n minus right. So this will give me the count of all those subarrays satisfying the condition, and will be storing for each left, will be storing answer equals to answer plus n minus right. Now once we are over here, we try to move the pointer of left. Now left is pointing over here. Still we find that count of 3 is greater than or equals to 2. It's 2. So this window is for sure, we need to have this window. So how many subarray we can have including this subarray? So we can have this as well including this. Same thing, we apply the formula. We'll be getting ans plus equals to n minus right. Now we are done with this right. We are done with this left. Now we move the pointer of left towards here. Now we see that this subarray doesn't have the count of max element as 2 or greater than 2. So we simply increment the right. Now right is pointing towards here. Now we see that is satisfying the condition. So we need to take this array. We need to take this subarray. How many subarray? We can only get one from here. So we include in the answer and we then move our left. Now left is pointing over here. We see it's satisfying the condition. Again we increment the answer, and now right will go out of the bound. It will come out of the loop. So that's it. That's what we need to do. We need to just know that what's the count of the subarrays. That's all we'll be doing. So here we are in IDE. So we have the size of array, and we have taken out maximum value using this simple STL function. We have initialized answer as 0. Now let's see. Now for int right equals to 0 and right less than n, right plus plus, if nums of right equals to max value, then what we gonna do? We do count plus plus. We haven't initialized count over here. Let's initialize it. Int count equals to 0 and int left 2 equals to 0. Now while we see count is greater than or equals to k, so we know that this is the valid subarray. So we need to store the answer of it. And this is the formula that I have just deduced. we are appending that to the answer. And if nums of left max value, then we can do count minus minus, because we are losing that maximum value, so we need to do minus minus. At the end we do left plus plus. Pretty simple. Now return the answer. Let's try to submit it. Now I'm running the code. It has been accepted. Now I'll try to submit it. That was pretty simple. We solved it in just big of n. That's it for today, guys. If you found this helpful, hit like, maybe subscribe too, and I will see you in the next video.